Hi there! Today I'm going to show you how to level up the security of your Bitcoin full node by managing users and processes in a more compartmentalized way, and by hardening some aspects of your system. This is how you might have installed software when following video tutorials. You log in with your user. This user has sudo powers, which for all intents and purposes, give you root privileges. With this user you install all packages, modules, dependencies, and software that you are interested in. All these applications usually talk to each other, to peers over the internet, to other clients in your local network, and will run services that listen on different ports. Ports that might or might not be accessible from outside your computer. And again, all these processes were started by a single user, that has root privileges. A better approach would be to use your sudo user only as an administrator, and to add multiple users without root privileges, each running its own application. In Linux this is very easy to accomplish, by using services. Your super user account will administer these services, which are nothing more than single files where you can specify the behavior of the processes being run. So this is the plan for today. In part 1, I will start with a fresh installation of Ubuntu server, secure the access to it, and prepare the machine for our Bitcoin operation. In part 2, I will download, verify, and build all of the necessary software to run a basic Bitcoin and Lightning full node. Part 3 is where the fun begins. I will run our processes as services, in a compartmentalized and automated manner, by tweaking file and directory permissions, and managing user and group memberships. Finally, in part 4, I will create Tor hidden services for our listening processes, so we can access them from outside our local network. There are links in the description to monothematic videos and series about almost everything I'm going to do. Except part 3. As I said, this is the important bit. So, although I won't miss any step in parts 1 and 2, I am going to run through them. If you don't understand something, or you're confused, please watch the videos linked below. One last thing before I start. You will see me use a Raspberry Pi for this tutorial. I do this for convenience and demonstration purposes only. Raspberry Pis are closed source, so I strongly discourage their use for anything other than fun and games. And definitely not for running anything that touches Bitcoin in any way. I have just flashed a new Ubuntu server pre-installed image into a hard drive, which is plugged into a Raspberry Pi 4B. You can just download and install Ubuntu server in whatever computer you like. The Ubuntu server for Raspberry Pi is a live pre-installed image of the OS, where an SSH server is installed by default, as well as the user, Ubuntu. If you go along with a regular installation, you will be asked whether or not to install the SSH server, and you will be able to give the user and your machine, whatever names you like. From now on, I will refer to the Raspberry Pi as the server, which I plugged into my home router a few minutes ago. I don't recognize this IP, so that must be the server. I will SSH into it, with the user Ubuntu. On my first login attempt, I will be forced to change the default password, Ubuntu. And try again with the new password. Okay. I am in. To minimize confusion, every time I log into the server, I will change my terminal window profile into a dark one. I will be using the upper terminal window to copy-paste some commands, dependencies, config files and such, that I will need throughout the video. It is more a guide for me than it is for you. Remember that in the links below, you have resources where I go through much of what I am going to do, in greater detail. So, here we go. Part 1. First I will update and upgrade. This might take a while. Now I will make some changes to the SSH server's configuration file. Disallow root login. Disable password authentication. Make Ubuntu the only user that can SSH into the system. I will manually copy-paste my SSH public key into the authorized keys file. Instead of holding hotkeys on my local machine, I am using an external hardware security device to SSH. I will create a new SSH connection to test the new configuration. Now I can only access the server using public key authentication. I will allow incoming SSH connections only from within my local network. Please notice that by enabling the firewall, all incoming connections to any port are denied by default. Now I will install Fail2Ban, an intrusion prevention software that protects servers from brute force attacks. A jail for failed SSH login attempts is enabled by default. Now I will install the Tor daemon. I'm running a Raspberry Pi. Your architecture might be different. Now I will install the I2P daemon. I need a web server running as a reverse proxy. I will install NGINX and overwrite its configuration file. Tor is running OK. I2P, OK. NGINX, OK. Let's move on to the last step of part 1. I will create users for our main processes. They will not have sudo privileges, and I will have their login password disabled. So the only way of logging in as those users will be through my administrator user, Ubuntu. If you want to leave all those fields blank, add the option, geckos, with an empty string as the argument. None of the users I've just created is a member of the group, sudo. These users will eventually run the software that I will be downloading in part 2. I can log in as any of these users only from a user that has sudo privileges with the following command. I've just logged in as Bitcoin, and I'm situated at its home. I log out, pressing Ctrl-D. The etc group is a text file which defines the groups to which users belong. These are its last 10 entries, where you can see all of the user groups I've just created. We'll come back to this later. Under normal circumstances, I would download everything I need over Tor. Unfortunately, the Tor network is undergoing a DDoS attack, and I am forced to use ClearNet. Whatever the circumstances, if you're patient and choose wisely the time of the day, you will be able to do this over Tor. But I personally cannot manage it while recording a video. So please, use the Tor browser, and remember that every single command that fetches data from the internet can be routed through Tor. If you proceed it by Tor socks, or Torify, commands like git clone, wget, curl, gpg receive keys, and so on. Okay. So I'll go get the latest release of the Bitcoin Core client, verify its digital signature, and copy the binaries into user, local, bin. These will work on a Raspberry Pi. Done. Now let's go and get the ELECTRUM server. I will have to build it from source. So first I will download the necessary software. Now I will log in, as the ELECTRUM server user, download the GitHub repo, verify the signature, and build it from source. In the user's home directory. When the process is finished, you will get an executable binary file called ELECTRUM-S. It's at target releases. I will create a symbolic link pointing to it at user local bin next to my Bitcoin Core binaries. To build Core Lightning from source, first I will install some dependencies. Please note that I am logged in as Ubuntu. Now, I will log in as the Lightning user, install some Python requirements, and move on to download, verify and build Core Lightning. Again, I will create symbolic links at user local bin to 3 Core Lightning binaries. Now we move on to the Core Lightning REST server. First, some required installs. And then I will download, verify, and build it from the Lightning user. And finally, I will get Ride the Lightning from the same developers. Be patient. This might take a while. Okay. We're done with part 2 of this guide. We have all the binaries that we need, user, local, bin. The REST server, and Ride the Lightning, are also built and ready. Before I move on to part 3, I will disconnect, and show you how to simplify the SSH syntax, by creating a file called config inside the SSH data directory. I will use the alias Bitcoin for my server. Now I just type SSH Bitcoin. Before we begin, a quick word about users and groups. In Linux, when you create users, you also create groups. Users can belong to any other group. For example, user A can be a member of group B. I will represent this with an arrow. User B can be a member of group C. User C can belong to group A. You get the idea. Linux user groups are an awesome tool for managing user privileges. If these concepts are new to you, you should definitely research the subject further before moving on. There are helpful links in the description. So, I will begin part 3 of this guide by setting up Bitcoin Core. I need to add some lines to the Tor configuration file. This is the user Bitcoin. We will eventually set it up so that it will run Bitcoin Core. This is the user Debian Tor. It was created automatically for the sole purpose of running Tor, when we installed the Tor daemon in part 1. If you want to route your Bitcoin traffic over Tor, the user that executes the Bitcoin binaries must belong to the Debian Tor group. Log out and log in, or just reboot your machine. Let's set up Bitcoin Core's RPC authentication. First, I will log in as Bitcoin. Bitcoin is a member of the Debian Tor group. I will manually create the Bitcoin data directory. And I will allow access only to members of the Bitcoin group. Core Lightning and the ELECTRUM server need to have access to Bitcoin Core's RPC. We'll set up the cookie-based RPC authentication by downloading and running a single Python script. Save that output into a file, and make it readable only by the user Bitcoin. Now, write a Bitcoin configuration file. Add the output from the Python script. I will restrict access to the configuration file. We are ready to run Bitcoin Core, and start downloading the blockchain. The configuration file that I provided will make this happen over Tor and I2P only. Final checks. Tor daemon. OK. I2P daemon. OK. Here we go. Bitcoin, D. Look at all these files and directories. Let's follow the log. Cool. I am already downloading block headers. Everything is working. I have an onion address, and an I2P address. So, this will probably take a day or two to finish. Take a look at those headers. When they reach the current block height, blocks will begin to download. I'll see you on the other side. I have a synced Bitcoin full node. Now, I will stop it, because I am going to run it as a service. Services can only be managed by users with root privileges. But the cool thing about them is that you can set them up so that a process is run by a specific user. Service files are usually located in etc systemd system. I will log in as my Ubuntu user and create a service for running Bitcoin D. Before I go on, let me give a shout out to Staticus and Raspabold. The service files that you will see me use, I got from them. They are not only beautifully formatted, but they include some hardening directives that will tighten your Bitcoin server. You only need to slightly adapt them to your needs. So check out Raspabold. Links below in the description. Please pay attention to these directives. User Bitcoin. When the service starts, execute Bitcoin D, with some common options like the path to the data directory, and the config file. The service only requires the network to be up to start running. The service will restart automatically if Bitcoin D crashes, or stops running for whatever reason. As I said, there's some additional stuff here that you can research on your own. You get the basic idea. I need to enable the service, to make it start on boot. I will start it. The command, journal control, with the options, FU, will also show some useful logs. At this point, the user Bitcoin is running Bitcoin Core as a service, managed by the user Ubuntu. But there's something I would like the user Ubuntu to be able to do. And that is, to have access to Bitcoin Core's command line RPC calls. After all, this is my administration account, and I wouldn't want to have to change users every time I SSH into the server, to be able to get information about the most crucial process. Read that error. Please remember that I changed the permissions of the Bitcoin data directory, so that only the user Bitcoin, and members of its group, are able to access it. The RPC authentication cookie is located inside this directory. To fix this, I am going to make the user Ubuntu a member of the group Bitcoin. You might have to log out and log in, for the changes to take effect. Let's read the file, groups, @etc. There you have it. The group Bitcoin has Ubuntu as a member. Now the user Ubuntu should be able to get in. This is the file we need for accessing Bitcoin's RPC. But look closely. Only the user Bitcoin can read this file. Changing the permissions will not help, because Bitcoin Core will delete this cookie when it shuts down. I will stop the Bitcoin D service. The cookie is gone. And if I start the service again, it always defaults to the same permissions. So this is how we do it. We use Bitcoin's option, startup notify, which allow us to specify commands that will be executed after Bitcoin Core is up. In our case, we will tweak the permissions of the cookie file, giving read privileges to the members of the group Bitcoin. We can add this line to the Bitcoin D options in our service. Let's do that and test it. Okay. This is very important. Every time you make any change in the service, you need to run the following command. System control, daemon, reload. Give it some time, and look at the permissions of the cookie file. It works. Now let's do this another way. Try adding this line into the configuration file, instead of into the service. I need to edit the configuration file. When I created it, at the beginning of part 3, these are the permissions that I gave it. Now, as an administrator, perhaps I would want to have write privileges, in order to avoid changing users. These decisions are up to you. Just know what you're doing and you'll be fine. Remove the double quotes from the command, when adding startup notify to the configuration file. Give it a few seconds, and check the cookie file. Same result. So, we should have access to Bitcoin Core's RPC, right? Wrong. You didn't read the second part of the error. Notice that the Bitcoin CLI command is trying to look for the Bitcoin data directory in Ubuntu's home. In fact, when doing so, it will create an empty data directory, assuming that this is the first time that you run Bitcoin Core. Delete this directory and create a symbolic link pointing at the actual Bitcoin data directory in Bitcoin's home. Bitcoin Core's RPC should now be accessible by the user, Ubuntu. Now let's move on to the ELECTRUM server. We are going to make the ELECTRUM server user run the ELECTRUM server as a service. ELECTRUM server needs to have access to Bitcoin Core's RPC. So we need to make the ELECTRUM server user a member of Bitcoin's group. I will log in as the ELECTRUM server user, create a data directory at home, and write a configuration file for the ELECTRUM server. This is pretty straightforward. Specify your data directory, and the server's listening port. I will use the default, 50001. Ready to build the database. This is going to take a few hours. Run the ELECTRUM server binary, and specify the path to the configuration file. I will see you in a while. Done. Now I will write an ELECTRUM server reverse proxy configuration file for NGINX. Now I will run the ELECTRUM server as a service. User, ELECTRUM server. Runs the ELECTRUM server binary. Requires the Bitcoin D service to start. If stopped, it will automatically restart. And some additional hardening directives. Enable and start the service. The ELECTRUM server user is running an ELECTRUM server. Listening on port 50001. NGINX is listening on port 50002, also running as a service, under its own user. Now I will allow incoming connections to port 50002, only from my local network. To test the ELECTRUM server, I'll try to connect from an ELECTRUM wallet. It works. Now let's move on to set up Core Lightning. The user Lightning is going to run the Core Lightning client. Lightning must have access to Bitcoin Core's RPC. Therefore, I will make it a member of the group, Bitcoin. Moreover, I will set up my Lightning node over Tor, so Lightning must also belong to the Debian Tor group. I will log in as Lightning, create a data directory, and write its configuration file. I need to create the backup directory that I specified in the config file. I will also create my plugins directory, because I am going to run the REST server, as a plugin. Let's start Core Lightning. This is the same issue we encountered when I tried to access Bitcoin Core's RPC, from a user that didn't have Bitcoin's data directory in its home. Same fix. I will create a symbolic link, pointing to the actual Bitcoin data directory. No errors. That output comes from the REST server running for the first time. Core Lightning is working properly. So let's encrypt the wallet. Right. So let's run Core Lightning as a service. User, Lightning. Run Core Lightning at start. requires Bitcoin Core to be running. Restart the service if it stops for any reason. I will enable and start the service. We get an error. You can guess what it is, but let's try looking at the logs for clues. There it is. Core Lightning cannot unlock the wallet because it cannot read the password from standard input. Since I am running Core Lightning as a service, we cannot use the keyboard to type the password. So let's fix this. I will write my password in a file, and I will pipe this command into the execution of Lightning D, in the Lightning service. This provides my password as standard input, to the Core Lightning process, thus unlocking the wallet. Please make sure to restrict access to this file. I'll start the Lightning service again. No errors. The Lightning user is running Core Lightning as a service. What happens if my admin user, Ubuntu, tries to use the Lightning CLI command? Same issue we faced when trying to use the Bitcoin CLI command. Now, the user Ubuntu needs to have the Lightning data directory in its home. Create a symbolic link pointing to it. As with Bitcoin's RPC, we also need to have access to a specific file that grants access to Core Lightning's RPC. That file is called Lightning RPC, and it is located inside the subdirectory Bitcoin. We will grant access to this file, not only to its owner, Lightning, but also to members of its group. There is a specific Lightning D option for defining this file's permissions at boot. RPC file mode. For enabling RPC access, we need to allow for read and write permissions. Let's add this option to the Lightning service execution command. Right. As soon as we add Ubuntu to the Lightning group, we'll have access to that directory, and to the RPC file. So, in order for Ubuntu to be able to access Core Lightning's RPC, I will make it a member of the Lightning group. Remember to log out and log in. It works. Before moving on to our last service, let us review the permissions of our Lightning data directory files. I will restrict access to the configuration file and the logs. Now we are going to set up Ride the Lightning as a service. Let's log in as the RTL user and write a configuration file for Ride the Lightning. This file will already work with a Core Lightning node. Just make sure to change the password. Okay. 3 things. The path to the macaroon file. The path to the Lightning configuration file. And the path for a channel states backup. First, let's create that backup directory. Second, the path to the access macaroon file, which will allow Ride the Lightning to access Core Lightning. This file was created the first time we ran the REST server. We could make it accessible to the Ride the Lightning user, by managing group memberships and file permissions. But we don't have to, since the macaroon file is unique and unchanging. So I will just copy it to Ride the Lightning's home, and avoid further user group configurations. In other words, Lightning Core makes its RPC accessible through a REST server. Clients authenticate by proving ownership to the REST server macaroon file. If the Ride the Lightning user has access to this file, there is no need to make it a member of the Lightning group. So I will copy this file to Ride the Lightning's home directory, and make him the owner. Regarding Lightning Core's configuration file, Ride the Lightning doesn't really need it to work. If it can read it, you will be able to see it from its interface, that's all. So you can decide if you expose it or not. As things stand now, Ride the Lightning cannot read the configuration file. Only members of its group can. Back to the macaroon file. Nothing I've done regarding this file will make sense, if I don't heavily restrict the access to it. So I will make it only readable to its owner. Looks good. Now let's test Ride the Lightning. It works. Let's stop it and configure a Ride the Lightning reverse proxy service in NGINX. Done. Now let's run Ride the Lightning as a service. User, Ride the Lightning. Requires Lightning Core to start. Will restart if it stops. Enable the service, and start it. I will allow SSL encrypted connections to Ride the Lightning, only from my local network. Let's test it. It works. So, to recap what we've accomplished so far. I have installed a Bitcoin and Lightning full node, with a bunch of applications built on top of it. There are multiple processes, listening on different ports. But these processes are isolated from each other. By using services, run by different users. The firewall is enabled, and all listening services are only accessible from the local network. There's a jail for banning IPs that repeatedly fail to authenticate through SSH. And the only way in is by using public key authentication. And by the way, I hold the SSH private keys in a hardware security device. We are ready to move on to part 4. Where I will make all of these services available outside my local network. Over Tor. Without having to allow any incoming connections in the firewall. I will start listing listening processes I'm interested in. ELECTRUM server is available through the NGINX reverse proxy, on port 50002. For accessing Ride the Lightning through a hidden service, I will avoid the web server, and access it directly, on port 3000. The REST server is listening on port 3001. The SSH server listens on the default port 22. I will also note the Bitcoin network port 8333. Now I will create hidden services for these listening processes. My Bitcoin Core node already has an onion address. Let's test all of these hidden services, one by one. I will try to access my ELECTRUM server over Tor. It works. Now let's access Ride the Lightning through the Tor browser. Next, I will try to SSH into my server, over Tor. Pay close attention. I am going to get one of those errors that is easy to fix, but can be tricky to figure out. The issue here is file permissions. When you SSH over Tor, and have a config file in your SSH data directory, you need to heavily restrict access to it. Let's try again. And I am in. One of the coolest things about using services to manage my server, is that, after having rebooted it from anywhere in the world, over Tor, everything will be up and running. Without me having to do anything. Bitcoin Core is running. The ELECTRUM server is running. Core Lightning is running. Ride the Lightning, running. Now, I am going to connect the ZEUS mobile wallet to Core Lightning through the REST server. ZEUS will need the macaroon file, the onion address of the REST server's hidden service, and the listening port. ZEUS requires the macaroon file in hex format. Now I will move to my mobile. ZEUS wallet is connected to my core Lightning node. And finally, I am going to download the Bisq exchange, and run it connected to my Bitcoin node, over Tor. The Bisq executable binary file is at opt.bisq bin. To run Bisq, connecting only to your Bitcoin full node, over Tor, add the following options: BTC nodes, and use Tor for BTC. Bisq is connected only to my full node. Now you don't have any excuse for not building a Bitcoin Lightning server yourself, without relying on third parties who decide what free open source software you are allowed to use. Keep up with updates. Confront upcoming issues. Don't stop learning Linux. Be self-sovereign.